Hi everyone, this side Divyansh and welcome back to my YouTube channel. So in this video we are going to discuss about like the fundamental things and the low level things that mostly not many people studied in their college time, and they are not studying this stuff because they are not maybe curious for these things. And for my side, I was curious, so I just learned about these things, and I'm just making this video so that in future if somebody need this kind of content, then they can watch this video. And I'm not prepared anything, I've just mentioned some roadmap here, and I have some timetable, so like sorry schedule, and our topics things. Then I will just google it and just chat gpt it, and I will elaborate it, and that's all. And let's just start these things, right? So firstly we will start from the C language, right? So currently, like before this, I also want to say that, like, I'm currently in third semester. So what the thing are happening right now, like I read about the QA subjects. So I have got an idea, like why should people not interested to read a QA subject as a low level subject? Because many of the students in my college, I have seen that they get scared a lot with the subject name, if we named QA. So QA is very interesting things. It's interesting subject for me. I don't know why people not liking it. So for this, I'm just started a channel. So I will elaborate you all the things that we are going to study now. So firstly we will start with the C language, because C language is a fundamental thing, and I will recommend all of you that you should also start uh, with this C language. So I have a roadmap that you should uh, know mostly things, like we will be following the 20-80% rule, right? So we should know about all the things, that what things are happening behind the scene. So let me just give you the uh, what we say, the syllabus thing, right? So let me just see, where is it? Okay, urgent. Okay. C language. Let me open it. I don't know why it's not coming here. Wait a minute. Uh, okay. So this is a PDF, right? So let me just show you what are the things you just need to cover for the language. Okay. So for the C language, um, I would say this is our syllabus, right? Yeah. No, this is not our syllabus. Okay, let me see more. Okay, yeah. So this is our syllabus, right? Right. We have having the introduction of the components and systems. So we should about the memory thing, and processor, and input output devices, storage, operating system, concept of assembler, compiler, interpreter, loader, linker. You just google it. These are the simple things, right? Just google it and you will definitely know about it. And representation of algorithm, flowchart, pseudocode with examples, source code, these are also simple things. Just google it and you will just get hands on it. Then you will and eventually know it. And the programming basics things is like writing and executing first C program, right? And objects, executable code, right? So these are also easy things. Just google it and you will get to know about it, right? Operators, expressions using relations, mixed operands, type conversion, logical operators, all are the theoretical part. These all like if you know about any language, let's suppose you know Python, so these are easy things for you. Just know the syntax and you will eventually know, right? I will tell you the important thing that you don't found in another language. Like for example, in Python, you don't know about that what the things happening behind the scene. So for that, I am just going the important things. Not I'm not completing the whole things, but I'm going to tell you about the important things that no one like deeply read it, and you will not found it in many languages. So that's why I'm going to show you the important things only. So use of while, do while, multiple loop, these all things you will get into your Python language, and it's just read the syntax and Google it. These are also important, not important. They are like um, simple things, right? Now the unit 4, we have the topics that I found something unique here, which is call by reference and call by reference, right? So here we are using a call by reference and call by value. So why not we should Google it, right? So let me just open it and just write it here, tell me about this in C language. Keep it short and pointly, right? So just Google it. So call by value means it's a copy of variables is passed on to a function. Changes made inside a function do not affect the original value, right? And call by reference means the address of the variable is passed. Change made inside the function affect the original value. So let me just grab my typing pad. So let me just type. Okay, so now I have grabbed my typing pad. Let me just open my Excel draw. Um, yeah, where is it? Okay, okay. So it is calling like it's saying call what we say, yeah, okay. Okay, let me just see. Yeah, so we will be talking about the call by reference. So mm, okay, call by reference, and we have the concept of call by value. So you know what is the difference between here is that when we having any function and we are passing like any value, let's suppose we having a value of a, right? We will be passing here, and we will also passing this value same as this. Now once we are passing this value in call by reference, means that we are going to like changes made inside the function do not affect the original value. So in the value, when this function is called, like for example, you will be having int main example, like let's just copy paste it. This is our code, just pasting here, right? So this is our function, and once this function is got hitted, right, this function when we calling it, so this will create an instance, this will create an instance, this is create an stack, and inside this function a, and the actual value is here, the actual value will be present in our heap memory. Okay, it comes in stack memory. Okay, so this thing is stack memory, and the actual value will be stored in our heap memory. So let's suppose we are giving it 5, right? So we are like changing the value as it 5, and let's suppose if there was a value of a 10, and we are changing it to a 5 value, right? So now when this thing is called, then it will return our uh, return our 5, right? And when in the outside thing, if you print the value of a, it will be giving our 10, because it is not changing the actual value of a. But what happens in reference is that when you are calling this function, then it will create an instance and the function a is called, right? And the actual value which was present in our heap memory, which was present in our heap memory, and we are giving a 5 value, right? Before this the value was 8 equal to 10, but when we are just calling with a reference, we use another operator like on operator. You can see that we are using an this type thing, we don't use in a call by value. So you can see, like let me just paste it. So this is our syntax for the function calling with a reference. So when we do call with like this is changing the original value, right? So we are, let's suppose here it is 10, um, it is 5, right? So when we just named this value as 5, now when we print a, this will give the original value to here, right? So this is our change call by reference. I hope you now get it. Now let's just move to another thing. uh, yeah, so this whole thing, and recursive thinking, it is simple as well. It is a theoretical concept, you have to learn it. And the thing is now pointers. So pointers is also interesting thing, you should definitely know about it. Let me just grab a pointer PDF. um, okay. Unit 4. So let me just Google it and tell you about the pointers. Teach me pointers in C language. Simple. So pointer is a variable that store a memory address to of another variable. It allows directly manipulation of the memory. So you know what the thing is happening here. When you are like suppose int a and equal to 5, when you are just writing this statement, what is happening behind the scene is that int is our data type. A will be going into our like it will be creating a random address, right? There it will be creating a random address in our computer, right? Well, like and the address might be of 65023, right? This is our random address. And like you have home, and that is your address. So in the same way, the variable a is also having his home, and the address of his home is something like this, right? So when we are writing this statement in this way, then it will call our stack. So this all things is covering in this this way box, right? So now it is giving this is initializing a variable a, right? And the actual value when this thing is going to happen, this will store in our heap memory. This value just storing first our garbage value. This will firstly storing a garbage value, but after putting this 5 it will get 5 value here, and this will return into here. So now this value changes from garbage to 5. So this is our now uh, uh, the happening things, like how they think in storing the variables, right? Now for the pointer thing, you just know, like this int pointer is all is getting like this thing is like let me just paste it. This thing, I like I let me just tell you the difference first. What if this thing this, right? So difference is this: if you are pointing this will be storing in like stack memory, right? And this will be storing a garbage value, right? There will be a heap memory, and there is no value for heap, so this will be storing our garbage value, right? And the address of this like 624. What this thing is doing, it is directly getting our this address to here. So when we just print hash star uh, pointer, then it will print 624 as an address. This will be pointing our to address. So this is simply like it is directly changing the value into our memory whose address is this. So pointer is very simple. It is don't very don't very complicated thing. The normal variable, we are going to our address and the value is changing in that address, but in the star pointer thing, what is happening, it is directly going to the original address and directly changing the value. But here so many things are happening. It will first reach out to address, and then it will store in the stack memory, and then it will go the heap memory, and then it will return here. So this is very complicated, but in this directly changing the value, right? So this is all about uh, um, what we say, a pointer, right? So the dynamic memory, you will read it eventually. These are also important things, so just read it, it will not understandable to you in a very short time. So just read it. It is also used for memory storing, like storing the data in memory, how the data is storing in memory. So this is all that. And this is a there is a standard processor. So let me just google it for you. So now let's just okay. Okay, so let me just uh, file input output operation. So what does this mean? Like when you are just editing something in files, and you are opening the file, closing a file, then you can do it like first you are now do with the mouse, right? Like cursor, you so this cursor you do it with this, but you can also do it by coding. So how to be coding it? Like we are opening the file, so we will use this code. right? And there are so many modes. Do you want to read or write or append the data, right? So these are the modes for file, right? And we can close the file with this code, and right, we can read our code by character by character. We can line by line read the code, right? So this is all about the file input output thing, right? Now, what is the C processor? Let me just ask it, like, what is the need of what is the need of C preprocessor? C processor are the program that process our source code before it is compiled. So like before the structure, um, coding execution in C language. Okay. So see, firstly we will be let me just copy this, post it here. So here we will be writing our C program. This thing is like we will be writing our program in main, right? So this will be our program. This is a source file. This is basically our source file, and it is going to our compiler. So there will be a person whose name is compiler. So the work of compiler is to make an object file. So this will change this source file to an object file. So this will creating our object file. Okay, so dot obj, this will be creating our object file. So this person work, or this person whose name was compiler, is to make that source file into that object file. And after that, there is also a person, there is also another person whose work is to link all the libraries. So there will be so many libraries which will be present outside in the internet, and this will all include all the libraries, for example xyz library into this object file. So this worker is used to get all the xyz library into that object file. Okay, so after this will all compiled into an exe file. So this will get into an exe file. So this will make an exe file. And after this, there is also another person whose work is to loader, it will directly load our exe file. So when this happen, it will eventually got our execution. So our program will run now. Okay, so this is our uh, what we say, execution happening behind the scene. There is also a simple image which I'm not finding right now. Let me just, yeah. So yeah, it is like this. So this is an like overview, and it is a how things are like you usually compiling the things, right, in the C language. So this is all about it. And um, okay, now it is like, C process source code before it's compiled. Okay, that process our source code before it's compiled. Okay, So there are many things happening behind the scene before it is get compiled. Okay, so this will be our copy image. Okay, so this will be our C code, and before compiling it directly C source code, it will first pre-processing it, right, and then it will send it to our compiler, and that compiler code will send it to a assembler, and that assembler will then link all the libraries that I have told you, and then loader things happen, and then it will give our output to our RAM. Okay, so let me tell you about the RAM and ROM part. RAM means is that when you are doing any kind of function, then there is a table. Suppose there is a table and you are sitting here, so there is a table which will when you are using things, then it will work, and when you just shut down your computer, let's suppose this is your computer, and when you just shut down this computer, this table automatically disappear from the uh, from the RAM. So this is all about RAM, right? ROM will, what will ROM do? This will table directly back to this ROM, but in RAM this doesn't happen. This table in ROM will saved in ROM, but not in RAM, right? So allows inclusion. So how do we are pre-processing it? Okay, so allows inclusion header files, reducing redundancy. So hashtag includes getting all the standard input output libraries. Enables it hashtag define enables macro definitions to replace repeated constant. Okay, so this work is that if if and the def and if has include and exclude parts of the code based on the condition. Okay, so this work is like this, and so this thing is like code blocks define macros, reduces function call and override small primitive things. Okay, I also don't understand this in much way. If you are not understanding things, then just skip it and do the another thing that I am going to tell you. So now the like C language, you will now you have now idea what is C language, right? Now uh, just move to about the evolution of computers, right? So just will it. So in the early mechanical computers, there was a Abacus first made. Okay, and after that, this was made in 300 BC. Okay, and Pascal then come, who made Pascal's mechanical computer for the addition and subtraction, and then 1837 there was an analytical engine who made by Charles Babbage. Okay, design program mechanical computer. Okay, and then in 1890 there was a Herman Holter punch card based machine came. Okay, so these are electronic mechanical came in 1938, and first generation computer was a general purpose computer using vacuum tubes. So like there used to in 90s there were used to a TVs which are very big, and they used a glass type tube in there that TVs are very big. So these are the computers which was made in 1945. Okay, and after that there was a commercial business government that maybe some maybe that thing maybe became something after that. So in second generation we used transistors. Okay, just know, like, if you know a 1 2 3 line about thing, then it's better to know, right? So in the third generation we know about the ICs, so these are the things we get introduced. Okay, in fourth generation there was an entire CPU or a single chip. This came. Okay, and a GUI thing came. This was came, and also a PC. In the fifth generation, we are living right now. Here we are using AI, quantum computing, cloud computing. So this came. Okay, so this was the basic um, overview about um, our evolution of the computers, right? And now let me just uh, let me just keep it here. Okay, so how different devices are working. So for now I'm going to tell you, uh, let's suppose I will tell you about the mouse, keyboard, how this is working, and monitor. Let's just google it, what we can do. um, Something yeah, I think these things are enough to know. So uh, let's just google it. So this is our this is our mouse. It contains of DSP, mouse button, CMOS, mirror, okay, and a LED, and lens, and left button, light. Okay, so we are now aware about what are the things present in mouse, and now let's just google it into our uh, chat GPT. How mouse internally working. Okay, our computer mouse is an input device that detects our motions and translate into a pointer movement. Okay, types of my mouse is like use balls, LED sensor, laser mouses, trackable mouses. So um, working principle is like what we use, like we don't using we are using the wall rolls as the mouse rollers connected to the roll rotate encoding disk, light beams through generating electrical signals. Okay, sends data via USB or PS2 connection, uses a Bluetooth communication. Okay, let's just read about this. So the ball rolls as the mouse moves. Okay, rollers connected to the ball rotate the encoded disk. So there may be an encoded uh, disk present over here. Okay, so this is looking good. So this was a USB cable, left switch, scroll wheel. So this is our wheel, circuit board, side to side, outer casing, encoder, right? Okay. So roller is connected to the ball rotate. Okay, it will be connected to our ball rotate and encoding our disk. Disk mean it will be encoding our SSD card. And when light beams passing through the encoding, okay, जब like when the lights, red color light, so that thing is passing in this encoding disk, are interrupted and generating an electric signal, then it will create an extra signals, and after the signal are sent to computers to move the pointer, and that signal sent to our monitor, and they will getting this type of thing. If we are moving left, then it will be generating a signal, and then we are moving left, and if we are moving right, then it is generating a signal and it moving right. So this is all about the thing, yeah, like mouse. Now let's just about let me just keep it short. So okay, each key, like a key press detection, which will be detected by our switches. So each key has a switch beneath, and there is a membrane, and pressing a key completes a circuit. So there is a circuit in the uh, keyboard. So keyboard internal working. So like there is a keyboard, there is a top case, this is a plate, sound absorbing thing. Okay, so these you can see like here your yellow lines. This is our circuit. So when we press any key, then it is completing this circuit. Okay, and when this circuit is got complete, keys are arranged in row column matrix, minimize wiring. Microcontroller, there is a microcontroller in that circuit, which detect which key pressed. Okay, and then key presses into a scan code, so there may be a scan code, and it applies a firmware logic, and the scan code is sent to the computer via USB. Okay, so there, so what we do, we just first press the switch, and it will complete our uh, logic gate, like logic gate of that design, and after that it will be creating our scan code, and that scan code is sent to our device monitor with the USB, and the OS translates the scan code into a character, and then this scan code is giving a character, is generating a character. So this will display on our screen. So this is very simple. Now I think you got to know about it. Now also just tell me about same in for mouse. Let's just again um, know about the mouse. So there is a optical mouse, uses a LED and sensor. So there is a sensor present in our mouse, and this captures the x and y coordinates through our sensor, which will present our in mouse, and then it will send the like detects button clicks and scroll wheels movement. Okay, so it will be detecting all these things, and xy coordinates and clicks, and the wheel movement, and then it will be storing somewhere in our small chip inside our mouse, and then that there they'll be generating a signal, and that signal will be sent to our computer through an USB, and that the OS process that signal, and it will uh, uh, it will display that signal to our display. So this is our simple thing for mouse. Okay, so this, let's now completed monitor. You can discover it by yourself, just google it, and now let's just came to this thing. Okay, you know how computers are internally working, how things are going. So there is a proper good video um, which I found on YouTube. Let's just see it again. Firstly, let me tell you about the assembly language. Okay, so assembly. You know how our C language is written and how is this processing. So there are so many things. Um, Not getting that. Okay, so you know this thing. So you know, like we are writing things, like we are creating an integer in our C language, and then it will be storing our data. But inside more, there is also happening another thing, which is we our assembly language. This is the code language. Okay, so it will be there is an also another thing. Okay. So it is writing in this way. Move means that it will be moving this 4 into our system disk, and this move EAVX, it is moving our one digit to our um, SSD or some memory. Okay, and what it will printing. Okay, maybe this is another thing the system calls for write. Okay, so this line is like calling for write, and this line is for standard output. This line is for hello, printing hello. This line constant thing, and we don't need to say. So and after this we are calling a kernel with this command, and the system is calling for exit, system exit, and ev0, we are writing this for return code, and we are again writing this. So this is all happening here, and we are getting the data from this hello world, you know, and hello lan is like hello. Okay, so this is our more depth inside our C language. Mm. There is also something happens. I'm giving you an uh, let me just show you how is happening. Yeah, this thing.
Assembly language is a low-level
Okay,
programming language.
so you can see So this is our how um, our compiler looks. Okay, let me just. So you can see that this is our register. Inside our computer there are register present, there are call stack present, in trace present, breakpoints present, watch points present, symbols present, and counters present. Okay, and this is our sections settings. uh, okay, this is our setting section. This is our coding editor. We will be the code we seen recently, so the code we will be writing here. This will be our devices. Okay, and inside devices, maybe we are using LED. Okay, so there are Arduino, there comes an Arduino which where we use LED. So for that we use this LED switches. There are switches, push buttons over here, 7 segment display. Okay, and there is an 7 segment display and JT key. UI, I don't know about it, but yeah, this thing. Cortex private timer, Cortex A9 watching timer, watching timer, watching timer. So this is our thing happening more inside our C language. You know, like C language, then the Python. But in lower the C language, there is also a language which is assembly language. So this will be the C language. When we are it is compiling. So what is doing in compiling? So this thing happening in our assembly language. So in assembly language, it is more covering the things like how it is adding the some like there are registers. So let me just give you an overview, and you can say a gist idea about it. So where is my Excel row? So okay, so where is my thing? Okay, so when you are writing this, okay, in CPU, in language, you already have an idea. There will be an address 652. There will be an stack, and there will be an heap. And more in depth, what is happening? It will be storing this A into our register. Register is some kind of storage device, like chip that we used to have in our mobiles. So in the same way, there is register is also a storage device, a simple storage device. So this will be storing our 5 value here. So this will be storing our 5 value here. And after that, if let's suppose there will be an 5b, and b is also storing a value of 10. So this is our values. And after that, let's suppose there was an operation, for example addition. And for this addition, there will be a inside our computer, there is an ALU present. So there will be an ALU present. So they follow a more detailed thing, but I'm just giving a gist. So this ALU performs like this thing is converted into our binary thing. Okay, so binary code, this thing will be converted into our binary code, for example 101, and this thing is 1001. Okay, so this that when this thing happened. Okay, and when it comes into our ALU, what is the work of ALU? Like 1001. So this will be performing a algorithm. There is an so many algorithm for addition, algorithm for subtraction. So there are algo, this will follow a addition algo, and inside addition algo, this will return our output in a binary format. Let's suppose it is giving our 1011. So this is our output, and this output is like giving our 15. So this, I'm just giving you a rough idea. So this will be our 15. So this thing is happening, and after that it will return out to our return to our what we say return to our CPU language. So this thing is like you are getting this 15, and where this 15 it will be going to store. So this 15 is going to firstly store in our RAM. Okay, so when this RAM is stored, and uh, when we run this command to save it. Okay, so when we going to save it, then it will going to store it in our ROM memory, which is our permanent storage device. Okay, so this is an overview. Okay, overview, you can see. So this thing happening in this way, so you can see. Okay, now this is all covering like in this way. These are registers. Okay, so value are storing here, and the code will be written here. Okay, and will be printing here after pressing this thing. Okay, then this is like simple. Now you might have an idea how more things happening, more depth inside our C language. Okay, so how computers internal. Now let me just give you an things about the how computers work internally. Mm-mm-mm. There was a video. Mm-mm. Let me just grab it. Mm-mm-mm. Okay. Where is my channel? Okay. Mm-mm-mm.
The
So
heart
let's
of
just see this
absolutely
video.
any computing device, be it personal computer, smartphone, or a programmable calculator, is the central processor, or CPU. The CPU's main job is to execute programs, or code. What this actually means is that as soon as power is applied, the processor, hungry for executable code, starts consuming data from external memory. Just like a person reads a book word by word, the processor reads the program byte by byte. As long as power is applied to the circuit, the CPU cannot stop, and program execution continues forever. And just like a book is made up of sequence of letters, words, and sentences, computer memory is organized as an array of integer numbers called bytes, and each byte can take a value from 0 to 255. In order for the CPU to know which memory cell exactly it addresses, all cells are numbered, starting from 0. The ordinal number of a cell is called address. For example, memory cell number 300 has an address of 299. That's because cell numbers start from 0. Computer memory is very similar to a sheet of paper. You can write something in it that can be read later. There are basically two types of memory, read-only and random access. Read-only memory, or ROM, usually contains pre-programmed code, which is intended for the CPU to execute, while random access memory, or RAM, mostly contains temporary data either generated by the CPU itself or loaded by the CPU from external media during program execution. As the name suggests, read-only memory can only be read by the CPU, while random access memory can be both read and written to. This means that ROM retains data even if you turn off your computer. while RAM is erased every time power is interrupted. DIMMsticks installed in your PC or laptop is RAM, and BIOS chip is ROM. BIOS is a small program that is executed every time you boot up your system. Let's now take a glance at how it works. Imagine a very simple computing device consisting of a CPU and a ROM chip. The ROM chip contains a program called firmware. The name firmware suggests that it's a proprietary piece of software that can only run on a certain device. As the power is applied, the CPU immediately addresses the ROM chip in an effort to read program code that it could execute. Obviously, for that to happen, it needs to read data from a number of memory cells. So each cell is read by specifying its address, which, like was mentioned above, is its unique ordinal number. For the CPU to be able to tell the ROM chip the address of the cell it wants to read, all computers have a communication system called address bus. By design, it's basically a set of regular electrical wires that use binary system, that's ones and zeros.
So like how these are communicating, like CPU and our ROM is our storage device and CPU is our brain of the computer, and it process our data. So how this performing is like, there are these are his hands, or you can say it's like a connecting dots. For example, we have neurons in our brain, so in neurons are used like, when someone is talk to us, then neurons hit and it sends to our brain. In our cerebrum there is an area. Okay, so in the same way there are neuron endpoints. So this neuron talk to our external neuron point, which is of ROM. So there are A15, A02, A15 endpoints of neuron in CPU, and there are A02, A15 neurons in our ROM. So they will be communicating in this way.
Zeros to encode memory cell address. This method, in fact, is always used by computers to communicate numbers between devices. Imagine that the CPU wants to read cell whose address is 44,206. This is just a random sample number. It doesn't mean anything. Let us now open Windows Calculator and convert it to binary. The result is this binary number. Note that it has 16 bits. That's binary digits. So, exactly these ones and zeros, the CPU will put up on the address bus to read cell number 44,000.
So like when we just write this number 44206, so this will be converted into our what do we say, let me just write it here. So what first thing we learned about CPU, how CPU and ROM is interacting with our endpoints, with our neuron endpoints. And you will ask how many endpoints are there. You can answer it. There are 15 endpoints, A02, A15. Okay, so this is first thing we learned. Second thing is that, for example, there is a number 44206. So let me just write it over here, 44206. This is our number. This will when we write it in our keyboard. Okay, so there are keys. When we write it in our keyboard and the logic completes, it will send to our monitor. There is monitor. When we press 4, it will complete a circuit, and it will through a signal it will show here. We press another 4 here, another 4 here, it again go here, it will show here, and same way it will show here 44206. And what things are now happening inside this monitor? Monitor will be storing this into our stack memory and the heap memory. Okay, so we created a box, stack memory, okay, stack and heap. So this number will be an like address, random address will be storing. So 36, this is the address, and 44206, this number is going, and like for example this was a variable name and it is here storing here 4206, and this will storing where in more depth. It will be storing into our register, register. So register will be storing this number 44206, and after that where it is going, it will sending this data to our CPU. Okay, how is it sending this data? How is it sending this data? It, we remember the pre-processing thing in C language. Okay, so this thing will be compiled before compiled. It will compiling things happens here, and it will compile into our binary code, because computer only understand what binary language. And okay, so this will be storing our this this number. Let me just print it. Okay, so let me just again open my Meet so that I can. Okay, so let me just open picture movement. Okay, so let me just show you, like, this thing came. Okay, this thing came, this will be compiling this thing, and it will be storing it in this way. Okay, this is like converted into our binary code, because binary computer understand only the binary language. Okay, okay, so sorry, I got a mistake here. So this will, like, register will be getting this 44206. It will be compiling, and it will compiling to our binary, because computer understand only binary language. So this is our number 1010, and 1100, and 1010 1116. So we write our this number in this way, in binary language. Okay, so like, this is our, let's suppose if you come from India, then this is our Hindi language, and this is our English language. Simple, it is just a language. Okay, doesn't matter, it is very simple. Okay, so this is our English language, means it is a binary language. Okay, and you can see that how many digits present over here. If you see here, 4 4 4 4. Okay, so it is getting a 16 digits number. Okay, so these are 16 bits. We are like, how bits are storing inside our computer. So this is our SSD. So there are many pixels present over here. Okay, there are many pixels present over here. It contains, 1 byte equal to 8 bit. Okay, so there is a 1 byte present on this pixel. Let's suppose this is our 1 byte. Okay, and when we more elaborated, let's just big this 1 byte, it will be storing our 8 bit. So 1 2 3 4 5 6 7 8. So this is our 8 bit. How is it to storing it? Like this way. Okay, and once this thing happens, it will address to it will bend in this way. It will go like this way to communicate with CPU. Okay, now that this whole thing will be stored in our ROM or RAM. Okay, and now the work is to communicate with our CPU, so that it can perform some operations, whether it can be a addition operation or subtraction operation. Okay, so after how does it sending? this will be like this will bend to our neural endpoints, and how the endpoints will be designed. So A0 to A14, this will be present over here, and the number will be one by one display over here. So this will be communicating like in this way. Okay, you can see over here, and now it will
106.
be communicating.
Yep, it's that simple. Please note, and that is very important, the least significant bit, LSB, of the address, which is 0 in our case, will be put up at address line A0, while the most significant bit, MSB, will be at line A15. Address numbering, like everything in programming, also starts at 0. Because the address is always sent from the CPU to external devices and never in the reverse direction, the address bus is unidirectional, which means the CPU address lines are outputs and the ROM chip's address pins are inputs. So, all devices on a computer motherboard are connected to the address bus in parallel. But it's obvious that computer memory supports two types of communication, reading and writing. How would the memory chip know which operation exactly the CPU intends to perform? For that, computers use a signaling system called the control bus. It also consists of regular wires.
So like this was thing of the address thing. So we completed the address part over here. Now another thing come, which is like for controlling it, control unit, the work of control unit. The control unit will tell you about whether we want to read the data or we do some input, or maybe we want to some do changes, like do operations. So for operation part we have to write something. Okay, so this will be work of like reading or writing. There will be two things happening here.
And its two most important lines are read and write, designated as RD and WR. Please note, both the read and write signals are active low, meaning if the CPU intends to perform a read operation, it pulls the read line low. If it wants to write data, it pulls the write line low. These two signals are mutually exclusive because it's not possible to read and write simultaneously. The reason why read and write and other control signals are active low is power consumption considerations. Okay, so the CPU outputs the binary value of 44,206 to the address bus. Now, to let the ROM chip know it intends to read the contents of this memory cell, it also activates the read line. You might wonder now, why would the ROM chip need the read signal if read is all it can do, and the CPU cannot write anything to it? Well, thing is, the CPU has no idea what type of memory it's addressing. Actually, it doesn't care. So every time it wants to read something, no matter if it's ROM or RAM it's reading from, it will always pull the read line low. And in fact, the ROM chip does need the read signal, because it needs to know when exactly it's supposed to send the data requested to the CPU. Looks like now we need a mechanism to transfer data. And here comes to play the data bus. Probably the most important and also complicated communication system in a computer. And it's bidirectional. In our example, the data bus carries exactly 8 bits of data. Because the size of the data bus directly affects the performance of the entire system, it is precisely this that we mean when we say, for example, that the computer is 8-bit and the game console is 16-bit and the version of Windows is 32 or 64-bit.
So like the work of when we get the information for control unit. So like let's suppose we having the operation came here, which was of add. Okay, so for adding thing we will go to our cu means control unit. So we will get this our write function, because we will be adding the things. So address thing will give, like let's suppose this will be our address a plus b, this is our operation. So there is an unique address for a and there is an unique address for b. Okay, and like this is of 16-bit address, right? And this is also a 16-bit address, and this 16-bit address for like adding it, what we go to our cu and we are getting our write operation. And how this data is going to our like there are so many components present in our inside more computer. So let's suppose there is a let me just see in my uh, okay, let me just see one, wait a second. Let me just type it. Mm-mm. No, this is not the same. Let me just see. So you can see, like, this is our um, things how happening, the overview. This is an overview part. In this, more things are happening inside the things, right? Okay, so for this is a simple thing. And now I don't know where this came. Okay, let me just grab it fast. Okay, got it. Okay, I'm not getting it here. Let me just find another video for like sort. That diagram is literally very important. Okay,
Hello and welcome those to the 5 minutes.
so you can see, yeah, this is a diagram. So we are storing our data. There are so many components, memory unit, this is our address register, this is our program counter, this is our data register, accumulator, in like INPR it's also a register, and IR, TR, out TR. So how this happening things is like this way. So let me just play this video for you. So this is an important architecture.
16 वापस हो जाएगा अगर करना है राइट करना मतलब क्या आपकी जीरो मेमोरी वीकली हर एक लोकेशन को एड्रेस करने के लिए टू रेजिस्ट्रेशन करना है, लेकिन रीड करना है या राइट करना है। तो वो देखो यहाँ पे हम लोग क्या करते हैं, आरडी पास जो है उधर जीरो लगा दिया, यानी मैंने बोल दिया रीड करना है। देखो ना, अगर जीरो है मतलब रीड करना है ना, तो जीरो मतलब रीड करना है, लेकिन राइट में क्या आएगा, मतलब जाएगा। अब ये भी वही बता रहा है क्या रीड करना है कि डब्ल्यू आर पॉपुलेशन मैंने आपको डेटा बस एड्रेस बस कॉमन बस मतलब क्या, कुछ नहीं, कॉमन बस मतलब वो इन तीनों को कैरी कर रहा है, आपके एड्रेस बस को, डेटा बस को, आपके एड्रेस बस को, डेटा बस को और कंट्रोल बस को कैरी कर रहा है। तो ये आपकी कॉमन बस होगी जो तीनों को होल्ड कर रहा है। अब वो कॉमन बस देखो इस तरीके से डायग्राम में आप यहाँ पे पूरी तरीके से देखने को मिलेगी। ये पूरी कॉमन बस ये जो आप देख रहे हो ना, ये पूरा आपका कॉमन बस है। इसमें मैंने क्या किया है, 16 बिट का कॉमन बस लिया है। आप लोगों को 16 बिट का कॉमन बस लाके, क्योंकि जो मेमोरी यूनिट मैंने यहाँ कंसीडर किया है वो वही आपकी 4096/16 वाली है। समझ पा रहे हैं, 4096/16 वाली है। तो सर जी 16 बिट कॉमन बस लेने का क्या लॉजिक है इसमें सर? क्योंकि जैसे अभी सर आपने पहले बताया था कि इसमें जो एड्रेस बस है वो कितने बिट की होगी, 12 बिट की होगी। क्यों? क्योंकि 4096 आपके एड्रेस रजिस्टर का है, बराबर, ये एड्रेस रजिस्टर का है, ये बात अपने को अंडरस्टैंड करनी है, ठीक है। अब चलो एक एग्जांपल लेते हैं, एक एग्जांपल लेते हैं, लेट्स से इट्स समथिंग लाइक दिस a प्लस b, समथिंग लाइक दिस, ठीक है। अब ये ऑपरेशन मुझे परफॉर्म करना है, अब ये कैसे होगा, ये पूरा फ्लो कैसे चलेगा, क्योंकि यहाँ पे तो आपने देखो 7 1 2 3 4 5 6 सर जी कुछ तो लिख रखा हुआ है, ये S2 S1 S0 सर जी आपने क्या कौन सी तीन पिन दे रखी है, ये रिस्पेक्टिवली बस यूनिट को, यहाँ पे मामला क्या चल रहा है सर, यहाँ है क्या, यहाँ पे भैया आपका मल्टीप्लेक्सर काम कर रहा है, मार्क्स 8/1, क्यों 8/1, क्योंकि आप यहाँ पे देख सकते हैं इनपुट लाइन कितनी 1 2 3 4 5 6 7, तो 7 इनपुट लाइन है, एंड टोटल भैया आपने तो जो है यहाँ पे 8 मेंशन की हुई, तो जो एक लेट से आपकी रिस्पेक्टिवली इनपुट लाइन होगी टू रिस्पेक्टिव मार्क्स, लेट से वो रिजल्ट होगी या फिर नॉट यूज, नॉट इन यूज, हम लोग ऐसे कह सकते हैं रिजल्ट होगी नॉट इन यूज होगी, लेकिन यहाँ पे जो बची हुई आपकी 7 इनपुट लाइंस है, ये वही है जो यहाँ पे प्रोवाइड की जा रही है आपके मार्क्स को, लाइन नंबर 7 1 2 3 4
Marks you can understand like it's an like adding things. It happens for it uses over for adding things. Okay, so just remember it in this way for simple thing.
5 6 ये वही है जो कि आपके मार्क्स को प्रोवाइड की जा रही है, और ये आपके मार्क्स के क्या है, S0 S1 S2 ये क्या है, ये आपके सिलेक्ट 1 2 3 4 5 6 7, तो 7 इनपुट लाइंस है, एंड टोटल भैया आपने को जो है यहाँ पे 8 मेंशन की हुई, तो जो एक लेट से आपकी रिस्पेक्टिव इनपुट लाइन होगी टू रिस्पेक्टिव मार्क्स, लेट से वो रिजल्ट होगी या फिर नॉट यूज, नॉट इन यूज, हम लोग ऐसे कह सकते हैं रिजल्ट होगी या नॉट इन यूज होगी, लेकिन यहाँ पे जो बची हुई आपकी 7 इनपुट लाइंस है, ये वही है जो यहाँ पे प्रोवाइड की जा रही है आपके मार्क्स को, लाइन नंबर 7 1 2 3 4 5 6 ये वही है जो कि आपके मार्क्स को प्रोवाइड की जा रही है, और ये आपके मार्क्स के क्या है, S0 S1 S2 ये क्या है, ये आपके सिलेक्ट लाइंस है, तो देखिए यहाँ पे ये क्या भैया 2/3/1 ये आपका रिस्पेक्टिव मार्क्स है, तो ये 3 जो है ये डिनोट करता है कि आपकी कितनी सिलेक्ट लाइंस रहनी चाहिए, क्योंकि ये सिलेक्ट लाइंस पे लेट्स से अगर मैं 0 0 0 दे देता हूँ, इसका मतलब क्या कर रहा हूँ मैं, अपने रिस्पेक्टिवली इनपुट जो लाइन 0 है, देखो इसको नंबर से कर देता हूँ 0 1 2 यहाँ पे 3 4 5 6 7 इस तरीके से, अगर सिलेक्ट लाइन पे भैया तीनों अगर बिट 0 कर दी, इसका मतलब यहाँ पे मैं क्या कर रहा हूँ भैया 0 जो इनपुट है उसका चुनाव करने वाला हूँ, और वो मेरा आउटपुट पे आपको देखने को मिल जाएगा, एक्टिव हो जाएगा, एक तरीके से आप ये समझ लो, ठीक है। अगर मैं यहाँ पे 0 0 1 कर देता हूँ तो यहाँ पे क्या रहेगा, यानी कि ये वाली इनपुट लाइन में सिलेक्ट कर रहा हूँ, ठीक है। उसके बाद मैं 0 1 0 यानी यहाँ पे 2 यानी कि मैं अपनी जो ये इनपुट लाइन 2 है उसे सिलेक्ट कर रहा हूँ, लेट्स सिलेक्ट है, तो ये फंडा आपने अंडरस्टैंड करना है, इसलिए यहाँ पे 3 सिलेक्ट लाइन मैंने प्रोवाइड करके रखी है, इसमें 0 दिख रहा है आपको, इसमें 0 दिख रहा है, तो उसी का इस्तेमाल यहाँ नहीं किया, ठीक है, ये अपने को समझना है, इनपुट लाइन 0 यहाँ इस्तेमाल किया हुआ आपको दिखाई नहीं देगा। तो यहाँ देखो एडिशन ऑपरेशन अपने को परफॉर्म करना है a और b के बीच में, सबसे पहले तो अपने को a जो है वो यूनिट में डालना पड़ेगा, तो उसके लिए हम पहला इंस्ट्रक्शन ले लेते हैं एज लोड a, तो ये a जो फंडा आपको दिखाई दे रहा है ये अपने यूनिट के अंदर लोड कर देंगे, ये इस इंस्ट्रक्शन का कहना है, लेकिन सबसे पहले मुद्दे की बात ये बताओ कि सर जी a कितने है, a कहाँ है, ये तो मेमोरी के अंदर है, उससे भी पहले ये बताओ सर जी ये इंस्ट्रक्शन कितने है, ये भी तो मेमोरी के अंदर ही है जी, और उस इंस्ट्रक्शन का एड्रेस क्या है, मतलब किस मेमोरी लोकेशन में ये लोड a आपका इंस्ट्रक्शन मौजूद है, उसका एड्रेस कहाँ है, प्रोग्राम काउंटर, मैंने कहा था जब रजिस्टर्स की बात कर रहे थे यही से सारी कहानी शुरू हुई, प्रोग्राम काउंटर कंटेन्स द एड्रेस ऑफ द नेक्स्ट इंस्ट्रक्शन टू बी एग्जीक्यूटेड, तो अभी पहले से फेच करना पड़ेगा, लोड a इस इंस्ट्रक्शन को फेच करना पड़ेगा, फिर डिकोड करना पड़ेगा कि कहना क्या चाहता है, एंड देन विल राइट टू एग्जीक्यूट, बात समझ में आ रही है, तो चलो ठीक है, लोड a इस इंस्ट्रक्शन का एड्रेस प्रोग्राम काउंटर के पास इतना सब पता चल गया, अब लेकिन कोई कॉमन बस भी अवेलेबल होना चाहिए, जब कॉमन बस में अवेलेबल होगा तब जाके वो रिस्पेक्टिवली देखो यहाँ से ट्रैवल करते हुए आपका एड्रेस रजिस्टर में एड्रेस जाएगा, और यहाँ से एड्रेस बस के थ्रू भैया आप जो है उस मेमोरी लोकेशन को सिलेक्ट करोगे, वहां से भैया आपका रिस्पेक्टिव इंस्ट्रक्शन निकलेगा और इंस्ट्रक्शन रजिस्टर में बैठेगा, ये बात अपने को समझनी है, इंस्ट्रक्शन आपका कहां बैठता है, इंस्ट्रक्शन रजिस्टर में, विल राइट टू एग्जीक्यूट, बात समझ में आ रही है, तो चलो ठीक है, लोड a इस इंस्ट्रक्शन का एड्रेस प्रोग्राम काउंटर के पास इतना सब पता चल गया, अब लेकिन कोई कॉमन बस भी अवेलेबल होना चाहिए, जब कॉमन बस में अवेलेबल होगा तब जाके वो रिस्पेक्टिवली देखो यहाँ से ट्रैवल करते हुए आपका एड्रेस रजिस्टर में एड्रेस जाएगा, और यहाँ से एड्रेस बस के थ्रू भैया आप जो है उस मेमोरी लोकेशन को सिलेक्ट करोगे, वहां से भैया आपका रिस्पेक्टिव इंस्ट्रक्शन निकलेगा और इंस्ट्रक्शन रजिस्टर में बैठेगा, ये बात अपने को समझनी है, इंस्ट्रक्शन आपका कहां बैठता है, इंस्ट्रक्शन रजिस्टर में, इसलिए मैंने पहले रजिस्टर का जो गहन चर्चा है वो पहले ही कर ली थी, ताकि इस पॉइंट पे जब पूरा डायग्राम एक साथ आपके सामने आए तो आपको डर लगने का कोई भी चांस ना रहे, ठीक है जी। तो यहाँ पे फंडा यही होगा कि मैंने चलो अपना रिस्पेक्टिवली जो फंडा है यहाँ इंस्ट्रक्शन रजिस्टर में इंस्ट्रक्शन लाना है, लेकिन सबसे महत्वपूर्ण मुद्दा आपको मैं बताने वाला हूँ कि ये सब दरवाजे बंद है, ये सब दरवाजे बंद है, अब हमें कौन सा दरवाजा खोलना है ताकि ये रिस्पेक्टिवली एड्रेस आपका प्रोग्राम काउंटर कॉमन बस में अवेलेबल हो सके, ऑब्वियस सी बात है, रिस्पेक्टिवली प्रोग्राम काउंटर किस दरवाजे के सामने खड़ा है, दरवाजा नंबर 2, अगर वो दरवाजा नंबर 2 के सामने खड़ा है, इसका मतलब क्या निकलता है कि अपने को ये जो S0 S1 और S2 ये जो सिलेक्ट बिट्स है इनका कॉम्बिनेशन क्या रखना होगा, इनपुट देना होगा 0 1 0, अब जैसे आप 0 1 0 दोगे ये रिस्पेक्टिवली बंद दरवाजा खुल जाएगा, जैसे ही दरवाजा खुल जाएगा आपका रिस्पेक्टिवली जो एड्रेस है रिस्पेक्टिव इंस्ट्रक्शन का वो फ्लो करेगा, और वो आपका यहाँ पे कहाँ जाएगा, एड्रेस रजिस्टर के अंदर जाएगा, फिर आप यहाँ पे रीड करना चाहते हो वो रीड करोगे, वहां से आप ना राइट नहीं करना चाहते, आप उस रिस्पेक्टिव इंस्ट्रक्शन को मेमोरी से रीड करना चाहते हो, जैसे आप रीड करोगे ऑब्वियस बात है वो इंस्ट्रक्शन आपको इंस्ट्रक्शन रजिस्टर में डालना है, तो क्या करना पड़ेगा, ये दरवाजा खोलना पड़ेगा, क्योंकि वो इंस्ट्रक्शन यहीं से आएगा और आपकी इंस्ट्रक्शन रजिस्टर के अंदर जाएगा, तो ये दरवाजा खोलना पड़ेगा, जहाँ पे मेमोरी यूनिट कनेक्टेड है, जिसके सामने जो दरवाजे सामने खड़ी है, बात सही है कि नहीं, तो यहाँ पे क्या होगा, फंडा आपका दरवाजा खोलने के लिए आपको ये बिट्स क्या रखनी पड़ेगी 1 1 1, तब जाके ये रिस्पेक्टिवली फंडा सिलेक्ट होगा और यहाँ पे दरवाजा खुल जाएगा, और फिर यहाँ पे इंस्ट्रक्शन रजिस्टर अंदर आ जाएगा, अब उसके अंदर जो रिस्पेक्टिवली ये वाला फंडा है, ये इसका अंदर जो आपका इंस्ट्रक्शन मेंशन है उसका देखो अलग मोड हो सकता है, अलग मोड में डायरेक्ट हो सकता है, इंडायरेक्ट हो सकता है, डायरेक्टली रखा जा सकता है या रजिस्टर में रखा जा सकता है, वो जो भी फंडा यहाँ पे आपका जो ऑपरेंड है वो किस तरीके से स्पेसिफाई किया है वो एक मोड बताता है, एड्रेस मोड के बारे में डिटेल में चर्चा होने वाली, डोंट वरी अबाउट दैट, बट मेरे को ये भी तो मानता है, तो मैं क्या करता हूं भैया रिस्पेक्टिवली उसका जो एड्रेस रजिस्टर में रखेंगे और वहां से भैया उस एड्रेस पे जाएंगे, उस लोकेशन से उस ए को उठाएंगे, उस ए को उठाने के बाद वापस से ये दरवाजा खोलना पड़ेगा, क्योंकि हमें वो रिस्पेक्टिवली ए जो है वो यहाँ पे कॉमन बस में अवेलेबल करवाना है, तो ये खोलना पड़ेगा, ये दरवाजा जैसे ही खोल देता हूं तो ये मेरा डेटा ए जो है वो डेटा रजिस्टर के अंदर आ जाता है, अब जैसे वो डेटा रजिस्टर के अंदर आ गया यहाँ से देखो ये रास्ता भी जा रहा है, देखो 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 गौर से देखो, ये देखो डेटा रजिस्टर से ये चीज एक्यूमुलेटर में जानी चाहिए, अब फिलहाल यहाँ एडर कनेक्टेड है, एडर एंड लॉजिक कनेक्टेड है, यहाँ से सीधा वो आपके एक्यूमुलेटर में चला जाएगा, तो यहाँ मेरा क्या आ गया भैया ए आ गया, तो सर जी चलो ये काम तो हो गया कि यहाँ पे जो है फंडा अपना ए आ चुका है, इसके बाद एक और इंस्ट्रक्शन है ना जी, इसके बाद अपने को ऐड बी वाला फंडा करना है, मतलब एक्यूमुलेटर में जो मौजूद है, एक्यूमुलेटर में जो मौजूद है प्लस ये जो बी है जो किसी में मंगवाओगे, जैसे ए को मंगवाया था, लेकिन उससे पहले ये वाला इंस्ट्रक्शन एड्रेस के पास होगा, विच इज द नेक्स्ट इंस्ट्रक्शन टू बी एग्जीक्यूटेड, तो वो आपका रिस्पेक्टिव प्रोग्राम काउंटर होल्ड करेगा, वही सेम प्रक्रिया जो हमने इस इंस्ट्रक्शन के लिए की थी, वही सेम फंडा भैया ऐड बी के लिए भी करेंगे, ये इंस्ट्रक्शन भी आपका इंस्ट्रक्शन रजिस्टर में आ जाएगा, बी वाला जो फंडा जिस तरीके से ए को मंगवाया गया तो उस एड्रेस रजिस्टर में डलवाया गया था, और वहां से भैया उस लोकेशन पे जाके बी को फेच किया गया था, फिर उसको डेटा रजिस्टर में डाल दिया गया था, तो अब यहाँ पे डेटा रजिस्टर में क्या है, गौर से सुनो, डेटा रजिस्टर में क्या है, बी है, एक्यूमुलेटर में क्या है, ए है, दोनों का एडिशन करूंगा रिजल्ट जनरेट करूंगा, देखो यहाँ से बी आएगा एडर को जाएगा, और यहाँ से एक्यूमुलेटर वाला फंडा, गौर से देखना, यहाँ से जो है यहाँ से एक्यूमुलेटर वाला फंडा जो है एडर एंड लॉजिक को इनपुट दिया जा रहा है, यानी ए और बी आपने दे दिया और वो ऐड कर देगा, ऐड करने के बाद जो रिजल्टेंट है वो कहां स्टोर हो रहा है, रिजल्टेंट भी आपका रिस्पेक्टिवली एक्यूमुलेटर के अंदर ही स्टोर हो रहा है, अब फर्दर लेट्स से आप उसको क्या कहते हैं टेबल रजिस्टर में डालना चाहते हो या आउटपुट रजिस्टर में डालना चाहते हो, लेट्स यू वांट टू पुट इट देयर लाइक दैट वे, तो आप क्या कर सकते हो, ये जो दरवाजा खोलना पड़ेगा, अगर ये रिस्पेक्टिवली आपको जो रिजल्ट एक्यूमुलेटर में पड़ा हुआ है A+B का, ये अगर आपको कॉमन बस में अवेलेबल करवाना है तो आपको S0 S1 S2 का जो कॉम्बिनेशन क्या करना पड़ेगा, यहाँ पे S0 है, यहाँ S1 है, यहाँ S2 है, तो कॉम्बिनेशन क्या करना पड़ेगा आपको, यू हैव टू सिंपली पुट इट एज 4, तो 4 क्या होता है ये फंडा, ये होता है 4 आपका, सही बात है, ये 1 ये 2 ये 4, तो ये 4 में भैया बंद कर दिया, तो यहाँ पे फंडा क्या आ गया आपका, दरवाजा खुल गया, दरवाजा जैसे खुल गया तो ये रिजल्ट यहाँ से फ्लो करेगा कॉमन बस के थ्रू जो है वो आप टेम्पररी रजिस्टर में भी दे सकते हो, फर्दर मोड ऑपरेशन परफॉर्म करने होंगे, फिर वहां से आप इस रिजल्टेंट को A+B को वापस यहाँ से कॉमन बस पे लेके डेटा रजिस्टर में डाल के वापस फर्दर कुछ ऑपरेशन, जैसे फॉर एग्जांपल A+B के साथ मुझे क्या करना है, ये C+D का मामला जो है, लेट्स से C+D वाला मामला जो है इसे मुझे क्या करना है, मल्टीप्लाई करना है, लेट्स मुझे मल्टीप्लाई करना है, तो जिस तरीके से A+B का जो रिजल्टेंट है वो एक्यूमुलेटर के अंदर स्टोर किया था, तो लेट्स से यहाँ पे मेरा जो रिजल्ट 1 था यहाँ पे टेम्पररी रजिस्टर के अंदर फिलहाल ये टेम्पररी बेसिस पे स्टोर कर दिया, ठीक है। अब C+D का सेम वे जैसे A+B है तो उसी तरीके से C+D का भी मामला एग्जीक्यूट होगा और यहाँ पे फंडा क्या आ जाएगा, रिजल्ट R2 जो है वो एक्यूमुलेटर के अंदर स्टोर होगा, अब मुझे क्या करना है, इंस्ट्रक्शन है MUL मल्टीप्लिकेशन A plus B into C plus D ये वाला फंडा इन टोटलिटी मुझे इंप्लीमेंट करना है तो ये जो मल्टीप्लिकेशन ये इंस्ट्रक्शन मुझे परफॉर्म करना पड़ेगा सेम इसका भी एड्रेस प्रोग्राम काउंटर में वैसे फेच किया जाएगा और फिर फाइनली आपका रिस्पेक्टिवली डिकोड करना होता है आपके रिस्पेक्टिव इंस्ट्रक्शन कहना क्या चाहता है डिकोड करना होता है उस हिसाब से आप क्या करेंगे टेंपरेरी रजिस्टर में जो रिजल्टेंट R1 A plus B का रिजल्ट जो कैरी कर रहा है R1 है C plus D का जो रिजल्ट कैरी कर रहा है R2 एक्यूमुलेटर के अंदर ही है यहां से आपका जो है R1 कॉमन बस को सप्लाई किया जाना चाहिए क्यों किया जाना चाहिए व्हाई शुड बी क्योंकि ये डेटा रजिस्टर में जाने वाला है आप समझ पाइए डेटा रजिस्टर में जाने वाला है इसलिए आपको दरवाजा खोलना पड़ेगा अगर ये दरवाजा खोलना है तो 6 लगाना पड़ेगा 6 के लिए भैया क्या होता है कोड आपका 011 फ्रॉम LSB टू LSB ठीक है तो यहां से आपका R1 होगा यहां से आपका R1 होगा और डेटा रजिस्टर में जाके आपका R1 बैठ जाएगा तो एक्यूमुलेटर में क्या भैया C plus D R2 रिजल्ट है बराबर जो अभी हमने कैलकुलेट किया और ये पहले का जो कैलकुलेट किया होता है A plus D उसका रिजल्ट R1 टेंपरेरी रजिस्टर में स्टोर किया था वहां से उसको वापस लेकिन हमने फेच करवाया ट्रांसफर करवाया इनटू डेटा रजिस्टर इस तरीके से अब मेरा डेटा रजिस्टर में R1 है एक्यूमुलेटर में R2 है अब दोनों को मुझे क्या करना है एज पर इंस्ट्रक्शन 1 मल्टीप्लाई करना है जो कि यहां पे भैया किया जाएगा देखो R1 यहां से घूम के एड्रेस को इनपुट किया जा रहा है एक्यूमुलेटर में जो भैया R2 है ये फंडा भी आपके एड्रेस को यहां पे इनपुट किया जा रहा है एड्रेस लॉजिक यूनिट को और वहां से फंडा भैया मल्टीप्लाई करके जो रिजल्टेंट होगा आपका लेट्स से जो रिजल्टेंट है वो R3 जो फाइनल रिजल्टेंट है उसे अपन जो है यहां पे एक्यूमुलेटर के अंदर की स्टोर करेंगे अब ये जो
So this thing happening is like in this way. Okay. So these are the things. There are also more in-depth questions, like in-depth things present doing opening it. But the overview of the how the things are going one by one. So this is like in this way. Okay. Now let's just move to our previous video.
In response to the CPU's request,
So data was a register. Okay.
chip
It will be
puts the
storing our
contents
data.
of the memory cell located at address 44,206 onto the data bus. Let's say the value is 112. Naturally, the data will also be presented in binary format. 112 will look like this. While the read operation is in progress, the CPU becomes the receiving side, and its data bus lines act as inputs, and the ROM chip's data bus pins act as outputs. Our little computer here has an 8-bit data bus, which means the size of a single memory cell is 1 byte, which is exactly 8 bits. So, our CPU has read exactly 1 byte of data, and its value equals 112. Like I said before, the ROM chip contains firmware, a computer program and machine code written by a programmer. So 112, which is again just a sample value I picked, is the command that tells the CPU to perform a certain task. These commands are also called operation codes, opcodes, or machine code instructions. So, imagine it's the instruction to write a value of 205 to the memory cell located at address 62,088. Please allow me to add a RAM chip to write to our improvised computer. It will be connected in parallel to both the address and the data bus of our system. Like I said, the address bus is unidirectional, and in theory, we can connect an infinite number of devices to it. But now we got a problem. When the CPU initiates a read or write operation, because we now got 2 memory chips in our system, how would they know which one the CPU is addressing? If both of them get activated simultaneously, their outputs will struggle, and we're going to have a collision on our data bus. Here, another very important mechanism in computer engineering comes into play. It's called address decoding. The term decoding here has nothing to do with ciphering or encryption. It's merely a set of logic gates that output logic 0 whenever a certain pattern of 1s and 0s is present on its inputs. What exactly this combination should be is determined by the circuit of the decoder itself. So, in order for the CPU to know exactly which device it's addressing, when designing a computer system, all address space is divided into ranges. Some part of it is taken by ROM, another part by RAM. Imagine a book that has several chapters. We know exactly which page each chapter starts and ends in, and it's impossible to move chapters if the book had already been printed. Same thing happens in a computer's address space. Each memory device is assigned a certain address range, which is fixed and can't be altered. The size of the entire address space is determined by the number of address bus lines and is always tied to the CPU model. Our computer here has a CPU with 16 address lines, so the maximum number of bytes the CPU can address is 2 to the power of 16, which is 65,536 bytes, or 64 kilobytes. You can also come up with this number using Windows Calculator. 16 binary ones will yield a decimal value of 65,535, because memory cell number 1, mind you, has the address 0, not 1. So the address space of our computer starts at byte number 0 and ends at byte number 65,535, and the total number of bytes that can be addressed is 65,536. For the CPU to be able to work both with ROM and RAM, we need to wire them in such a way that they're activated whenever accessing the address range that is assigned to each of them, based on our concept. Or we can say these 2 chips must be properly decoded. To keep things simple, in our little experiment, each chip will have exactly half the memory space, which is 32 kilobytes apiece. ROM will take the lower 32K, and RAM the upper 32K. So the ROM will be located in the address range from 0 to 32,767, and RAM from 32,768 to 65,535. Why exactly like that, and not the other way around? ROM is usually placed at the start of the address space because that's where a typical CPU starts program execution after the reset signal arrives. When you hit reset, what you actually do is zero the program counter, PC. So address 0 is where the very first firmware instruction must be located. All data between the CPU and memory chips will naturally be transferred in binary format. Here's what it's gonna look like. To be honest, these numbers do not really fit well with the ear and are pretty hard to perceive. So, in computers and programming, a hexadecimal numbering system is used. It differs from decimal system in that, in addition to digits from 0 to 9, Latin letters from A to F are used, that also act as digits. So hexadecimal uses a total of 16 digits instead of 10. In essence, the hexadecimal system is a simplified way of representing binary numbers. It basically boils down to a simple replacement of every combination of 4 binary digits, there are also 16 of them, with one hexadecimal digit, like this. So 8-bit of binary data can be represented by 2 hex digits, while 16-bit of binary data will take up 4 hex digits, and so on. By the way, in programming, 4 bits are called a nibble, 8 bits are called a byte, and 16 bits and up are called a word. Now these values will look like this, and our ROM chip will decode to addresses from 0 to 7FFF, while the RAM chip will take up address range from 8000 to FFFF. We must pronounce hex numbers by a single digit, because 8000 is not 8000, it's a different number. Hex numbers have their own designation in programming. For example, the C language uses prefix OX, while in assembly language, Latin letter H, H for hex, uppercase or lowercase doesn't matter, is appended at the end of the number. All these designations are equivalent. Okay, let us take a close look at these values and try to figure out how they differ in terms of address bus bits. Their binary representation tells us that their distinct difference is their most significant bit. Any hex number in the range above 7FFF has the highest address line, that's A15, equal to 1. Any hex number below 8000 has address line A15 equal to 0. So we need the ROM chip to activate when A15 is low, and RAM chip to activate when A15 is high. Memory chips have a special control line for activation called CS, chip select, or CE, chip enable, which is basically the same. The CS signal is also active low. If the IC is not active, its outputs will be in the so-called C state, high impedance, which means that the pin is effectively disconnected. Such outputs are also called tri-state. Memory ICs also have the OE control signal, which stands for output enable. Since ROM can only send data, the CS and OE there have basically the same meaning. But for RAM, active OE means the data is being read from the memory. So, to decode these two memory ICs, all we have to do is use a simple inverter gate. The ROM C signal will be wired directly to the A15 address line, and RAM C will be fed from the inverter. The read signal will be wired to the output enable pins of both chips, while the write signal will go to the write enable input of the RAM chip. The write signal is not used with the ROM chip naturally. Before us, ladies and gentlemen, is the real working circuit of the simplest computer. So how does it work? Once the CPU is reset, its address pointer, the program counter, PC, is zeroed, so all address lines are set to logic 0. As the CPU immediately starts reading program code from memory, it sets the read line low. Because the CE line of the ROM chip is also pulled low by the A15 address line, the ROM IC activates and puts up the contents of the requested memory cell, address 0, on the data bus. Although RAM is wired to all buses in parallel, it does not interfere, because it's not active. Its CS input is fed logic high from the inverter, and its data lines are in the C state, effectively disconnected. Now imagine the CPU reads the opcode that instructs it to write byte AA 170 decimal to address B000 45056 decimal. The CPU sets its address bus to this value in binary format. Then it puts the integer number AA, which is 10101010 binary, on the data bus. The AA and 55 bytes, alternating zeros and ones, is the value often used in programming for memory testing. So we got the binary representation of AA integer on our data bus. What happens next is the CPU pulls the write line low, and the RAM chip, mind you the A15 is high and CS is low, which means it's active, performs the write operation, storing value AA in a memory cell whose address is B000. Now this data is stored, and whenever the processor needs it, it can read it. To do this, it has to set the address bus to B000 and pull the read signal low. The chip enable line of the RAM chip will also be pulled low by the inverter, and it will place the contents of the memory cell B000 on the data bus, and the CPU will read it, switching its data lines to input mode. Okay, so we have created a contiguous address space of 64 kilobytes, covered by 2 memory chips. The CPU has no idea about this structure. It simply accesses a cell by address and receives data, and each of the memory ICs responds to the CPU based on which range the address requested belongs to. In real computers, decoding is of course much more complex. The decoder can use several address lines and other signals to obtain a narrower address range. Using this mechanism, several memory and input-output devices can be decoded. In any case, it's up to the developer to decide which address range each memory chip must be decoded. And when firmware is written, the programmer naturally must be aware which devices decode to which address range. For example, every personal computer has this thing called display memory area, also known as video RAM or VRAM. It's basically your regular random access memory. However, writing data to it changes the contents of the computer screen. Typically, VRAM memory cells are located according to their position on the screen, that is, from left to right and from top to bottom. The lower address is the upper left corner. The higher address is the lower right corner, although there may be exceptions. Now, we have studied a very important mechanism that explains the interaction of the central processor and memory devices. With this knowledge, it's easy to understand the principles of operation of any computer. But it seems our virtual PC is missing something. It does not in any way interact with the user. All real computers, in addition to memory, have input-output ports. This is where you plug in your keyboard, mouse, or gamepad. To work with ports, the CPU also uses read and write operations, but they are decoded into a separate address space and accessed with separate machine language instructions. The address bus used, however, is the same, so to separate ports from memory devices, there exist additional signals on the control bus, called input-output request, IO-REC, and memory request, MEMREC. Traditionally, their active level is also low. So, for the CPU to be able to talk to memory correctly, we must also decode the memory request signal. Here's what the schematic will look like then. Now, both memory chips can get a logic low on their chip-enabled inputs only on condition the memory request line is also low. So, what are we going to do with our little computer now? Say we want to impersonate Arduino and flash an LED. Let us add a simple 1-bit output port to our system. We will use a D-type flip-flop to implement it. The data input will be wired directly to the data bus, while the clock input needs to be properly decoded. Let our port use the address FF. This number corresponds to 8 ones in binary. Like I said, CPU uses the same address bus to decode ports, so we will need an AND gate with 8 inputs to track this combination on the address bus. Our port will be write only, so we also need to decode the CPU's write line. The device must react only to port output instructions and ignore memory write instructions, so we also need to decode the input-output request signal. If we don't, the CPU won't know how to differentiate between memory cell FF and port number FF, and when it performs a write operation, both will be affected. Okay, let us analyze the circuit step by step. Say the CPU wants to turn on the LED, so it executes a machine code instruction that writes value 1 to port FF. As we have wired the flip-flop D input to the D0 line, the state of the LED will correspond to the least significant bit, LSB, of the data byte. So, the CPU sets the address lines from A0 to A7 to 8 ones, that's value FF, and puts up logic 1 on D0 line. Then it pulls the write and input-output request lines low. At this very moment, the flip-flop will be clocked at the C input, and data will be copied into the register. The LED will illuminate. To turn the LED off, the CPU must perform exactly the same action, except the value written to the flip-flop port must be 0. This principle of parallel connection and individual addressing of peripheral devices with the help of decoding has been used in computer engineering for decades. And that's exactly how ISA and PCI buses in personal computers work. All slots in such systems are connected in parallel, and decoding happens on the expansion cards inserted. If you've ever used the ISA Sound Blaster, you remember you had to set up its address and interrupt line. What you were actually doing is setting up its decoder chip. So any expansion card can be inserted into any slot and will work the same way. However, starting with the PCI Express bus, manufacturers have abandoned this principle, and today each motherboard slot has independent lines for communication with every individual expansion board installed. And that would be it for today. I hope you enjoyed this video and learned something new. If you did, make sure to give it a thumbs up and hit the subscribe button if you haven't already. And please don't hesitate to share it on social media.
This was the video which I like, and I just played it to know you so that you can also understand. And the things are now like how computers have changed, like we have AI coming, so we have to study more about the AI things. And in the phase 2 I was like going to tell you about there was foundations thing, type into hardware hierarchy, build a computer. So you can Google it, okay, but the overview I want to give you is like, I still want to tell you what are the things are still left that you should definitely go and check it out. And the things are like, So this is a core subject which we will study in our uh, third or fourth semester when you come in second year. Then this subject is very very important to uh, like if you really want to understand the low level things. Okay, so I'm not getting why it's okay. So this is a functional unit. In this unit you will learn about there are some buses, uh, like these are yellow things, um, like you have a computer and inside our laptop, like let's suppose an example of the laptop. So inside our laptop there is a motherboard of a laptop. So you can see this is our motherboard that we have in our laptops. Okay, so these are some parts. This is our touchpad in our laptop. This is our serial port, RTC battery. uh, it is like a battery, embedded flash, backlight, power supply, LCD supply, USB per switches. Okay, and yeah, you can see here is RAM. Okay, it's MMMC slot and power supply, battery charger, embedded backlight, LCD power, HD code, processor. Okay, so these are the things you will see in your laptop, and inside it you will also see these yellow lines. uh, where is let me CPU internal parts. Where is it? So um, you will see these type of yellow lines when you see the motherboard. So these are our you can say like buses. These are buses. Okay, and for this they have a special logic to connect all over the components, and that thing is known as bus architecture. So that thing you will learn here. It is my thing, yeah. So that thing you will learn here, and you will know about the register thing, how the processor working. Okay, so you will know about it. Arithmetic logic means that how do you are doing operations inside our addition and what we say multiplication. So there are algorithm. You know how algorithm look like. Let me show you. For multiplication in Goa. So so this type of algorithm it is used to multiply our numbers. So these kind of algorithm you will read in uh, this chapter. And in the control unit it is like you will know about the instructions, in depth about like how when we give the instructions, what are the things present in our instructions, and how they are getting the data from our files. There are four steps. First it will fetch the things, and it will decode the things, and it will like in control unit it will do some things, and after that it will giving a output. Okay, so these are the things you will know in the instruction cycle. Instruction, first it will, we will give the instruction, and it we will like for example, if we are given an instruction for a, and a value is 5, so we will be giving this a value of 5 in our computer, like in memory. So we will be this will, like for example, let me give you an example. First we give an value, we a, let's suppose the value is 5. We will be giving this instruction, and this will send to our memory. Okay, and memory, and we, in where is the memory? So inside an address. Okay, so this will, memory will be having an address, and in that place it will be storing our 5. For example, the address is our 456. Okay, so this is our address inside our memory. So our 5 will be storing, 5 will be storing in our, in 459 address, 459 address, simple. Okay, and after that, if you want to multiplication, it will multiplication, if we want to multiplication, then it will get you know, it will what we do, we do algorithm, we know, like I already told you about how the algorithm. So it will follow the algorithm, and once this is done, it will store in our register the final result, the final result. Okay, so the final result will be stored in our register, and that will through the input output thing, we will be getting it into our monitor, because it will generate a signal. Okay, so this is the thing happening right here. Okay, and in our third, we will learn about, in the fourth unit, we will learn more about the memory. There are different types of memory. Cache memory, you will learn about cache memory. There is a register memory. Okay, register, there is a kind of like magnetic disk. Okay, and RAM, ROM, these kind of things. Okay, there are 2D RAM and 2.5D RAM. Okay, you will learn about the virtual RAMs, and magnetic disk, and the magnetic tape also you will learn about. So how the data is stored, like in this way. In the 15 unit, you will learn about, there are, you know, like in laptop we having the ports. So ports also play an important role for transferring data into our monitor. So you know, like there is a port which act as an interface. Okay, then it will be sending the data to our sending data or instruction to our motherboard. Okay, and this is an overview we will learn in this unit. So these are the claims that I just want to let you, all the people who are in college here, they don't study about these things, and these are very important thing that I personally believe, but I don't know why people not learning, and it will generate an interest in yourself. And in the phase 3, there is operating system and the software, like you will study eventually. In there is operating system and networking, you will I know the things, but it is better that you will study it in your third year. I am in second year, but I studied it also. So you can also study about the operating system and the networking things, the basic things. You will just Google it, and ChatGPT, you will get it, definitely go more about it. And in the fourth thing, I want to say that inside all the things that we have learned right now, like assembly language, we all the things that we learned about the bus architecture was inside more depth, there is also another thing, which is compiler design. So compiler design is give you a more microscopic level. It will cover a more microscopic coverage. So this is our fourth stage, and after that you will know lots of things in the low level design, low level, and how things are working inside of our computer. So these are the things I want to share you, and thank you for watching the video. Bye bye. and hope you like. I know I like before ending this video, I am giving a disclaimer that I mostly things I just right now I've been having exams, but I made this video so that we can after some time, like after 5 or 10 years, we can have a fast rapid revision of what we learn in our college. So for that I just made this video, and I may be wrong in somewhere because I'm also a learner, so I have not covered any book. I Once I will read more books, then I will get a more idea. So this was the things that I know, like on overview things type. Okay, so these things are what I learned in like last couple of 1 year, and what I found something interesting. So that thing I just covered in this video. I may be wrong somewhere, and that thing can, like, you will just if you finding something wrong, you can just google it and just chat gpt it. You will eventually learn it. I just gave you the terms that you have to read, and after that you can just google it, right? I also do same like in that way, so you can just google it. Okay, so that's all I want to say. Thank you, bye bye, have a good day, bye, and finish recording.